Hey, fellow mathers. Before we get into this episode, we want to share with you how you can get access to free content, professional learning that will keep your students engaged and doing the math that matters. Get ready to go to this link, mathisfigureoutable.com/challenge.
That's right. Registration is open for the free Math is Figureoutable Challenge that's starting May 15th and runs to the 17th at 7 p.m. Central. We're going to have 3 nights jam-packed with learning and routines that you can take straight to your classroom.
In these challenges, we have a great time. We do some math, talk about classroom experiences, give away super cool bonuses and prizes. You won't just walk away with routines that are naturally engaging and encourage your students to think mathematically. You'll also have a chance to win over $6,000 worth in prizes, including a few virtual PD sessions for your school. I'll be joined by my wonderful co-host Kim and special guest Jenna Labe.
You can register at mathisfigureoutable.com/challenge for a fantastic learning experience. That's mathisfigureoutable.com/challenge. Now on to the show.
Hey, fellow mathematicians! Welcome to the podcast where math is figureoutable. I'm Pam.
And I'm Kim.
And we make the case that mathematizing is not about mimicking steps or memorizing facts, but it's about thinking and reasoning, about creating and using mental relationships. We take the strong stance that not only are algorithms not particularly helpful in teaching, but that mimicking algorithms actually keep students from being the mathematicians they can be. We answer the question, if not algorithms and step-by-step procedures, then what?
So we're knee-deep into our series on addition facts, and we are finally ready to tackle our favorite and what we think is the most important relationship that everyone needs to know. And that is building partners of 10, right?
Yes, very, very important.
We say this often, right? That the 10s are super important and that we love the 10s, but why 10s? Why is that so important?
I mean, you say that we do say that often now, but early in my career in building my own numeracy as a high school math teacher, I didn't know.
Yeah.
And now it's amazing to me. It affects so much. What's one way, Kim? What are some things you're thinking about?
So if you know about 10s, then you know how it influences get to a friendly number. Because if you're at 43, then you know you're 7 away from 50, which leads to give and take. Right? The most important or the most sophisticated addition strategy.
Yeah. And so, for example, if I'm adding something like 43 plus whatever, then I can think about, well, I know 43 plus 7 gets me to that 50. And then I can sort of tack on what's left over and that's either get to a friendly number or give and take. Yeah. So how far away you are from that next nice number is really, really important. That leads to understanding in rounding. So we can literally use this understanding of how far away I am from the 10 to round numbers. It leads to success in subtraction across zeros. Now, if you're an upper grades teacher, I didn't know what that meant as a high school teacher. I was like, what even is that? So that has everything to do with like 1,000 minus something. Well, if I know my partner of 10, then that can help me figure out the partner of 100, which can help me figure out the partner of 1,000. And all of a sudden I'm not doing all of that, cross out the 0 and carry the 1, and then now it's a 9 and all that crazy stuff that happens when you're trying to use the subtraction algorithm when you have a bunch of zeros. No, you just sort of think about how far you are to that next nice number, and bam, subtraction across zeros. In fact, it affects subtraction in general. We can really use this idea of how far away we are to the next nice number as we think about using the difference or distance meaning of subtraction, that interpretation of subtraction, not just the removal meaning of subtraction. So as I'm subtracting to a friendly number, I'm thinking about partners of 10. Also, because it impacts subtraction so much, it's going to impact strategies that we use when we are doing multiplication or division. I mean, I can even give you just a simple example of if I'm doing something like, how am I figuring out 7/8? Well, if I know that 8/8 is 64, but I only need 7/8, then I'm thinking about, well, then I'm going to get rid of that 4 and I'm at 60. Now I got to get rid of 4 from 60. Like, am I writing down 60 minus 4 and crossing out the... No. I'm thinking about the partner of 10. If I know the partner of 10 with 4 plus what is 10 is 6. Well, then, bam, I'm at 56. As soon as I'm thinking about 16 minus 4, I just use the partner of 10 to do that subtraction. And I could do that with bigger numbers and more complicated numbers. It hugely impacts the way I'm thinking about multiplication, and maybe even especially division. As we're trying to think and reason using division, often I'm going to sort of multiply up to see, well, how many of these fit in there? Well, I've got so many. In fact, okay, now I'm wanting it. Here, Kim, help me out with an example. I wasn't going to give an example here, but I'm dying to.
All right, got my pencil.
Give me a division problem.
Like a 63 divided by 9?
Sure. So if I'm thinking about 63 divided by 9, I might say to myself, well, I know, I'm asking myself how many 9s are in 63. I might say, well, I know that there are 6 9s in 54. Well, how far away am I? If I know that fact, how far away am I? Oh, I'm only 9 away. So it's that idea of thinking about subtraction. And if I've got partners of 10, then I can think about that subtraction easier. Oh, okay, then I've just got one more 9 to get 7 9s in 63. I don't know if that was the best example, but this idea of being able to be fluent in subtraction, I need to have these partners of 10 to help me. That's going to help in multiplication and division. And you might be thinking, I mean, Pam, you might be dropping off the podcast right now because you're like, okay, but like I teach 8th grade, but remember Kayla in 8th grade? Remember Kayla in 8th grade was really struggling, or not struggling, but she was counting by ones. We need kids to know their partners of 10 so that they aren't counting by ones when we need them thinking in bigger jumps of numbers, bigger chunks of numbers. It's more sophisticated.
Yeah, so we go to lots of places, right? And hear from a lot of teachers who say, we share this with them. And a lot of times there's conversation around, my kids, that's not something they're automatic with. So this is not a K-1-2 situation only. This is definitely for older kids who've never been exposed to the importance of partners of 10.
Yep.
So we talked about this Apple rich task a couple episodes ago. I think it was the first or second of the series, about just bringing understanding to ways to make 10. So I definitely feel like there's some great places to start. I'm not suggesting that you're going to do that with your 8th graders, right? But
so maybe let me just, since it's been a couple episodes, so if you give young learners, hey, I've got 10 apples, I've got some green, some red. How many green apples, how many red apples? And I specifically used the total of 10 for this very reason, because 10 is so important that we're talking about in today's episode. But back there, I could have used, hey, we have a total of 6 apples, and the kids just could have been messing with different combinations of 6. And we want teachers of younger grades to use different totals, but also really use the total of 10 a lot.
Yeah.
Like often use the total of 10 because it's so, so important. Sorry for interrupting.
That's okay. So once you've given kids an experience with finding the partners of 10, then it's time to make some, that good repetition that we've been talking about with some games. And so we want to share a couple of our favorite games. The first one is Collect 10. So that looks like numeral cards that have just the digits up there. Do they have the 10s? Yeah, they would have 10. Yep. So 0 through 10 on the cards, and you lay the cards out in an array. It could be like a 5x5 array or a 6x6 array. You've got partners who are going to play, and they take turns, and their entire game is collecting a partner of 10. So one student might say, I found a 3 and a 7, and 3 and 7 make 10. I put my cards together, I set it aside. Then it's my other partner's turn. I'm going to find another pair of 10. So grab a 5, put those together, set it aside. They go back and forth until the entire game board is empty. You still have a deck of cards off to the side that you could refill in if you wanted to make the game a little bit longer. But that is Collect 10, a super popular game.
Yeah, let me just talk about what if you have students who don't know their partners of 10 yet? I've literally played this with kids who don't quite have them automatized yet. A student can pick up a 7, and then they can pick up a 4, and they can add them together and go, nope, that didn't work.
Yep.
And then you can decide if you want to lose a turn or whatever. We don't usually do that. We just like, okay, well then what will work? And then, kind of until they find the partner of 10, and then that's their partner. So you can also do it even if you don't have the facts automatized.
Well, and I'm glad you mentioned that, because once you have partners of kids who do have them automatized, then that probably isn't the best game for them anymore, right? If you already have all your partners down, then you're just going through the motions of a game. That's not meeting you where you are. However, you then might do turnover 10, which is the concentration version, where you have that same, I would do a smaller array at this point. It's more like memory. So maybe a 4x4 array or 5x5 array. Cards go face down. They turn the first card over. You get a 4. At that point, you have to think to yourself, what would I need to get 10? So 4 plus what equals 10? They flip over a card that's upside down. They say, oh, it's like 7, too much. At that point, I would say, how much too much? What would you be looking for? Nice. They flip both cards back over. Game continues to be played.
Yep. And now you just have that extra little concentration nudge. And that visualizing of what the partner is definitely a step up. There's the memory part of it that's like, where is it? That maybe is the less important part. But there's the sort of visualizing of like you said, well, what do you need if you popped over a 6? What is that partner of 10? Yeah, totally cool.
Yep. Probably my favorite game, because most kids have experienced Go Fish. So 10's Go Fish would be a version that we'd play instead of playing in a group. Instead of looking for, hey, do you have a 4 and you want the match 4 plus 4? At this point, you're holding a deck of cards, a group of cards in your hand. And let's say you have a 4, you're going to ask for its partner. So you have to consider to 10. So you have to consider, I have a 4. What do I need to ask for? Oh, I need to ask for a 6. I ask somebody, do you have a 6? They hand it to me. I say, I have 4 plus 6 is 10. And I set those cards down.
Now it's my turn. And then I'm looking at a 9. And so I say to you, do you have a 1? And you say,
nope, Go Fish.
Oh, man. Rude. And so then I go fish. I pull a card from the deck and we go on. So to differentiate this game, let's say you have students who don't know their partners of 10 yet, like at all. It's like really young, or I should say maybe really less experienced.
Yeah.
Then you might have that student actually do the matching game first. You might, if I have a 3, I might say, do you have a 3? And then if you do, I have a match. And if you don't, then I go fish.
Yeah.
If you have students that are just on the cusp, like they've done work with partners of 10 and they just need more experience to really get them automatized, this is a brilliant game because it's kind of fun and you have to, you get some time to sort of think about it. There's not a speed element involved, but you get a lot of repetition and it's kind of self-correcting, because if I say, I have a 4, do you have a 6? And then your partner's going to go, hey, or sorry, I should have goofed. I have a 4, do you have a 7? Your partner's going to go, hey, it's not a 7, it's a 6. And then you guys can sort of work it out and come to an agreement. So there's lots of ways that it's a really nice game for kids that are just needing that more experience, more practice. Would you agree with that?
Actually played 10's Go Fish with some older kids, and it feels less immature. So
like you're dumbing it down for them?
Yeah. There's other 10s activities that they know, oh, we're working on the 10s. This one feels a little less babyish, if you will.
Yeah, so kids are more willing to play. And so then you get good practice in as kids. So y'all, in this whole series, as we're talking about automatizing single digit facts, we're not suggesting that once you've mentioned a relationship that, okay, now we're done and we can just move on and do other things and kids magically own them. No, they need experience. It's just the kind of experience that we want kids to have is more like these games that we're talking about and a whole lot less speed, time, pressure kinds of things. When we give kids speed, timed, pressure kinds of things, then we know now that in many kids that can turn off their brain. They get flooded with adrenaline and they can't think. And so what we're really testing is more their sort of metal under pressure. And that's not math. That's not mathematizing. We want to help them develop relationships, literal connections in their brain. That's mathematizing. If you're interested in creating a kid that can take a test under time pressure, then at least admit that's what you're doing and go do it with some other subject. Don't do it with math because you're ruining math. You're making it equivalent to this idea that if you're good at math, then thou shalt be fast. And we just vehemently and fundamentally disagree with that proposition. Right. You can absolutely think deeply and carefully and purposefully about something. And that to us is more valuable than a quick answer.
Absolutely. So if you've ever heard Pam speak pretty much at all, you probably have heard her mention a routine that we absolutely love called I Have You Need. It's a great routine for working with combinations of 10, which leads to combinations of 100, combinations of 1,000 that we can do for older kids. Pam, you want to speak to I Have You Need? And
Yeah,
let her
and so
play
Kim
that?
actually made it up. So she's I'm going to give her lots of credit for I have you need. It's not I have who has, which is a different sort of
Yes, different
instructional.
routine.
It's a different routine. But I have you need. You specify the total. You say, okay, today we're working with a total of 10. And since we're talking about total of 10 today, we're going to kind of focus on that one. Total of 10. If I have 8, what do you need to make 10? And I could do this really early when students are learning to count. I can hold up 8 fingers and sort of flash those 8 fingers and say, how many? And when the kid says 8, then I can say, well, okay, this is 8. How many do you need to make 10? They can literally count the 2 fingers that are down. If you can see me, I'm holding up 8 fingers and 2 fingers are down. And my goal at that point isn't to have them automatize the partners of 10. My goal at that point is for them to learn to count, but I'm doing it with my fingers so that they start to get sort of that finger understanding, and they start to really develop the sense of 10-ness. And we're dealing with sort of partners of 10 as we learn to count. So it's a brilliant, I get lots of nice outcomes. But after students are counting and really we're trying to automatize the facts, then I can really just say, okay, partners of 10, here we go. Ready? If I have 9, what do you need? Kim, go ahead, just play with me
1,
real quick. If I have 7, what do you need?
3,
You need 3 to make 10. If I have 8, you need
2,
If I have 6, you need
4.
And now you might have noticed as I played that I just did numbers close to 10 first. And we would recommend that as you play with students, do numbers close to 10, because if they are counting up to find the missing number, then that's going to be easier for them to do. And I usually start with 8. If I have 8, what do you need? And kids can go 9, 10. Don't start with 9. That's too easy. Don't start with 6. That's too hard. Like start with 8, maybe 7. Like know your content, know your kids, know your kid well enough. I like to start with 8 usually. Then once kids kind of get the hang of the game and everything, then I said, if I have 8, you need 2. Then I might say, well, if I have 2, you need
8.
And then, so often kids will go, oh, crud. Because then they have to like count up from the 2 because it's like so much farther away. But then I might notice and go, oh, well, when I said, that's interesting. When I said 8, you said 2. When I said 2, you said 8. Huh? And then I might just go on and do another one. 7, 3, 3, 7. Oh, that's interesting. And just notice. And I'm going to notice for a while before I make even a bigger deal of it. And then sort of expect kids to stop counting up from 3 and start just using, oh, well, I knew 7 and 3. So then I'm going to know 3's partner is 7. But, we're going to talk about it. We're going to make that sort of a thing. We're going to play some more. We're going to talk about it some more, make it, if I know the partner, then I also know this one. Kind of like your number rack flipping that we've been talking about in the past couple episodes, Kim, that if I know 7 plus 3, then I also know 3 plus 7, that use of the commutative property. So we really like I Have You Need. It's a fabulous way to promote kids really thinking about partners of 10. And y'all, you might be thinking, okay, Pam, but I'm a teacher of older students who don't know their partners of 10.
Right.
Really? Really? You want me to play I Have You Need partner of 10?
Yeah.
Actually, maybe not. So here are a couple things that you can think about. One, you can help your student. You can help your students think about partners of 10 by doing total 100, but do the decades. So you can say, well, if I'm trying to get to 100, if I have 70, what do you need? Well, that's like 7 10s. How many 10s do you need? And you're kind of working on the partners of 10, ostensibly working on the decades. Now you kind of have to know your kids to know if that's going to work, but that's a thing. Now it's kind of bigger numbers. Doesn't feel like I'm babying it or dumbing it down.
Well, and I'll tell you, Pam, that when I was teaching third grade, I absolutely played I Have You Need with partners of 10, but it was early, right? It was early, not at the end of the year. And, it makes me think of some of my partner teachers who would say, one in particular, and I had this conversation about, it's like middle of the year, my kids don't know their partners of 10. And I remember saying, if they came to you not knowing the partners of 10, you cannot blame the people.
Well, that's a bummer, right? If they come to you, if they come to you,
it's December. And so what have you been doing about it? And so I start the year with a real quick Like, this is a check kind of thing, not a gotcha, but just like, hey, we're going to do this routine, and notice who still needs to work on that combination of 10 and who I can move on with decades or partners of 100.
Yeah. So y'all, if you say to yourself right now, oh, my students don't know their partners of 10. Okay. Then let's
We got to do
build them.
something.
Like,
Yep.
let's do that. Let's develop those partners of 10 right now. Like, as soon as you realize that that's a thing, let's do it right now so kids can begin to use it. Another way that I would have you consider, teachers of older students, is to use problem strings that are get to a friendly number. So I might do a problem string that's something like 47 plus 3. And then I'm not going to spend a lot of time on that. I might say, okay, 47 plus 3, especially if I'm doing this. I mean, I think I could do this problem string in high school. In fact, I've done it with adults before, where, all right, what's 47 plus 3? And they say 50. And then I just say, oh, nobody needed to draw anything for that, but I'm going to go ahead and do that. And I'll put 47 plus 3. That's 50. Okay. And then the next problem is, what's 47 plus 25? And then I'll say, I wonder if you could use the problem before to help you. I don't know, maybe not. Go ahead, solve it any way you want. But then I'm for sure to go find somebody who used the 47 plus 3 to then think, well, that's 50. So then what's left over? Well, I was supposed to add 25. So what's over is 22. So now I'm thinking about 50 plus 22. And I'm for sure going to pull out that thinking. Notice that in that problem string, I'm dealing with 7 plus 3. Right? Like 47 plus 3. I'm nudging that partner of 10. And so I'm just exposing students to how important it is to think about getting to that friendly 10. Oh, I need to know that partner of 10, and then adding what's left over. It's a brilliant way to sort of develop these partners of 10 in older students without dumbing it down, making them feel like you're, like you said, it's kind of like, I don't want it to be a gotcha, or I can't believe you don't know these. No. Let's just do the work. Let's expose, let's experience, let's do it. Let's get that brilliant kind of practice in to develop those relationships in your students. All right, y'all, if you're interested to know more about these TENS games or I Have You Need, if you want the TENS games, you can go to a bit.ly link, bit.ly/partners of 10 games. Oh, so I said that wrong. bit.ly/partner. I can do it. Partners of TENS games. Partners of TENS games. We will definitely put the link in the show notes. That's the best place to get it. But also, if you want more information about I Have You Need, we have a super cool blog that also has a free download on it at mathisforgettable.com/you need. Like the word you, Y-O-U, the word you need, mathisforgettable.com/you need. You can get information, a blog, there's a video, and a free download all about I Have You Need.
And if you've been loving this series, you will definitely want to check out the Building Edition for Young Learners workshops that are currently open for registration. And if you're itching to hear more about multiplication facts, then the Building Powerful Multiplication workshop is for you.
In both of those workshops, we go into far more detail and a lot more explanation and how to in your classes about building single-digit addition facts and single-digit multiplication facts. So check those out. Registration is open for my workshops through February 4th. So head on over to mathisforgettable.com/workshops is where you can find out all the information about the workshops that I'm currently offering. If you're listening to this podcast at a different time, then you can join the wait list at mathisforgettable.com/workshops. Same URL to either join the wait list if it's not during registration time. If it is during registration time, check it out. You can register for the workshop at that point. So if you want to learn more mathematics and refine your math teaching so that you and students are mathematizing more and more, then join the Math is Forgettable movement and help us spread the word that math is figure-outable. Thank you for listening and making math more figure-outable.
To learn even more, make sure you register for our free challenge at mathisfigureoutable.com/challenge. You are not going to want to miss the evenings of May 15th through 17th, starting at 7 p.m. Central.
Math teaching, go register now. That's mathisforgettable.com/challenge. Join us to make math more and more figure-outable. And if you can't join live, register and we'll send you access to the recordings. We'll see you there.